right? There's it can also subtract numbers, but we also have an analogy for subtracting functions, right? And we have an analogy for multiplying functions, right? But for functions, we have one more operation that there's nothing like it in arithmetic, and that is this one. This one here, number 3. Okay, remember this symbol? We talked about this. It just means this. So this means this. Okay, there's just 2 different ways of writing the same thing. This kind of tells you exactly what you have to do, whereas this is just like a kind of like writes it as though it's an operation called circle. Okay? This is like you're saying, you have an operation with 2 functions on each side. Right? So that's that kind of notation. But this tells you exactly what you're supposed to do with it. Okay? But it's just the same thing, right? Just kind of 2 different ways of writing the same operation. Okay? So we're talking about this operation where you take one function and put it inside another. Now you don't do that with numbers, right? You can't take a number and put it inside another number. That doesn't mean anything. Right? So there's no analog for this in numbers. But we do this with functions. And so we might ask, is there some way to, do a derivative of this, sort of in terms of the simpler ones? Just like over here, we wanted to do this one in terms of the simpler derivatives, right? The derivative of just the first piece and the derivative of just the second piece, or the derivative of just the first function and the derivative of just the second function. So, we kind of made it simpler by being able to do that. So is there some way when we have this situation to make it simpler? Okay? And it turns out that this is the answer. And this rule has a name. This one was called the product rule. And this one, we'll see why in a minute, is called the chain rule. So it doesn't reference the operation. So this one is called the addition rule, or the subtraction rule, depending on which one you're doing. This one is called the product rule. The other one is called the quotient rule. So they're all referencing their operation, but we don't call this one usually the composition rule. Remember, this is called function composition. This is called function composition, but I call it the composition rule, but it's usually referred to as the chain rule. Okay, and we'll see why. And that's a really important rule for, especially if you're studying, this new field called deep learning. Have you heard of that? Deep learning? That's part of AI. Yeah, and they use something called neural networks, and this is completely essential for that. Everything that a neural network does is just because of this one rule, or you use this rule to get the results. So when they're making driverless cars, just because of this rule. That's really the whole thing. Or when you take iPhone, when you take a picture, it recognizes where the person's head is. That's because of this rule. Or language recognition when you talk to your Siri or your Android phone, right? It's because of this rule. It's all because of this one rule. So it's called the chain rule. So anyway, and it's not just used in AI, it's used many places, but these days I've been thinking about AI a lot, and so I've been having to think about this all the time. Somebody's calling me. Okay, hang it up. Okay, so this is called, so we want to be able to do this. Now, which kind of function would this come up with? For example, can I erase these now? All right, I'll do it here. Well, when would this come up? This will come up when you do this, for example. Okay, now why is that? So let's go back and review composition, because before we talk about the derivative of composition, we better make sure we know what we mean by composition, right? So I don't know if I said this before or not, but maybe I'm repeating myself. But let's just do it again. So you remember when of course you remember when you had to learn things like 5 plus 2, right? How old were you then when you learned that? What age? 5? Okay, 5. What'd you say? What? 5. Okay, so you were 5 years old when you had to learn this, right? And how about when you had to learn this? When did we have to learn that? Maybe 5 or 6, right? 7, something like that, right? And, right, so we had to learn these things, right? So, of course, this is equal to 7, and this is equal to 24, right? And then I remember sometime after learning, for example, this, the teacher would say, okay, now, tell me, so we say that the product of 3 and 8 is 24, right? Then the teachers reversed the question. They said, give me 2 numbers whose product is 24, right? And I remember being stumped, or a little bit stumped by that at first. Like I remember my brain stopping for a moment, and finally you get it, right? You say, oh, okay, 2 times 12, or 3 times 8, or 4 times 6, right? Or 1 times 26, right? I mean 24, right? So you remember doing that? And you remember that this was a little bit hard at the beginning, right? But after you did it maybe 10 times, or 15 times, or 20 times, or 30 times, you got the hang of it, right? So what we're doing is now the same thing. Because if I give you an f equals, say, x to the 5th plus 2x cubed, and I give you a g, which is equal to x squared minus 8, and I ask you, what's f of g of x? Well, that's supposed to be easy now. So how do you do that? So it means you have to put, g into here, right? So this says whatever you put in there, you're supposed to raise the 5th and add 2 to the 3rd power of it, right? So if you put in f of 5, then of course you just add 5 to the 5th plus 5 to the 3rd, right? Right? If you put in 5 into here, you get 5 to the 5th, 5 to the 3rd, right? Okay? And so what does it mean to put g in there? So it means do the same thing. Raise it to the 5th, and so it just means do exactly the same thing. So it means g of x to the 5th plus 2g of x to the 3rd. Does everyone agree with that? Okay, so that's what we mean by f of g, right? Of course, we can expand this a little bit by putting in exactly what g is. But we already have the right answer now, right? But we could write it like what? X squared minus 8 to the 5th plus 2 times what? X squared plus 8. Right? Like that. Right? Okay? But all I care about is this. Okay? Everyone agree with this? Okay. So do we understand function composition? Okay? Let's do one more. Let's suppose we had e f of x is equal to e to the x, and g of x is equal to x cubed plus 7x plus 1. Okay, so just f of 1, here's f. F of 1 is what? E to the 1, right? F of 2, e to the second. F of 3, e to the third, right? F of 10, e to the 10th, right? Okay. F of A, e to the A, right? Right? Just put in, if you're putting an A, putting an X, you get that. Just when you get that. Okay. How about one more? F of A plus B, e to the A plus B, right? Okay, everyone agree with this? Okay, so what is F? So what is, all right, going back to here, what's F of G? E to the G, right? F of A plus B is e to the A plus B. F of G is e to the G, right? E to the G, right? It's just the same rule, right? It's there's nothing even to think about, right? Just do it, right? Just replace it. Okay, but then you can say, well, what is G? So we wrote G like this, so what? So the answer can also be written as e to the what? Here's G, so it's x cubed plus 7x plus 1. Right? So what is f of G? It's this. Right? Does everyone agree? Okay. Now, tell me what are the factors of 20, or tell me how I can write 24 as the product of two numbers. What two numbers multiplied to 24? 2 and 12. Okay? All right? So you know how to do that. Now what I'm asking is, suppose you have this, can you go backwards? Right? And find this as the composition. I'm not talking about multiplication. Right? We're doing composition now. So can you write this as the composition of two simpler functions? Well, we already know the answer. We just got this. Right? So we already know the answer is what? At least one. This and this, right? Right? If I do the composition of this, I get this, right? So that's the answer I'm looking for. Can you go backwards? Okay, so it's kind of like, just like when you had to go backwards with multiplication, it was hard at first, but if you do 10 or 15 or 20 problems, you get to see the pattern, right? You learn the pattern, right? So, for example, suppose I asked you to go backwards with e to the x to the 10th plus 6x to the 5th. So I want to find an f of g, I want to find an f and a g that give me that. So let me just use some words here. When we write f of g, we call f the outside function, and we call g the inside function. Okay? So I want to find an outside function and an inside function that will, when I do their composition like this, will give me this. So it's like I want to find 24 as the product of 2 and 12, but I'm not talking about multiplication, and I'm not talking about a number. I'm talking about this function and breaking it up by composition. So the second time is not that easy. but I made the problem kind of very similar to the first one, so that it's probably not that hard either. So so I want to get this. But I want to find f and g. I want to find the outside function and the inside function. Now, you can go back and look at the previous example to help you get through it. So what would the outside function be? What? E to the x, right? And what would the inside function be? Right? And when you put this into here, that means this goes up into here. Right? And that gives you what we wanted. Okay, so we could write this as the composition of two pretty much simpler functions, right? I think this is simpler than this, and I think this is simpler than this. Okay, so we're able to write it as the composition of two simpler functions. Okay? So let's do another one. Yeah. I think there are other possible ways. There could be, and I can't think of anyone for this one. Well, there is the trivial one, just like 24 times 1. You could use the let's figure out what is the trivial one. Like, what I mean by the trivial one is I can write 24 as 1 times 24, right? And in this case, the outside function could be e to the x to the 10th plus 6x to the 5th. Okay? So this is a trivial one. Now, but the tricky part is, what is g? What's so the 24 is the analogy is this, but what's the analogy to 1? That's a little tricky. G of x is equal to what? You might think it's 1, it's x, right? So if I put this into here, that means I put, wherever I have x, I replace it by x, which gives me what I need, right? So it's not 1. Okay, so that's like a trivial decomposition of it, okay, which is probably not usually what we would want. Okay? All right, let's try another one though. Let's try, suppose we have a function like, okay, how about this one? This is, maybe you won't get this one at first, but if you use the language of outside function and inside function, that might give it away. So we want an f, meaning the outside function, and a g, meaning the inside function. So that when we do their composition, f of g, we get that function at the top. So, what is it? Yeah. Okay, that's not the trivial one, that's the right answer. And? That's right, because we're asking, in that case, what would f of g be, right? And means we're going to put this into here, and that means wherever we see x in here, we replace it by g. So we'd have g to the 10th, right? Which is what we wanted. right? Okay, it's a little bit mind-bending at first, right? But you should be able to get it eventually. Okay, do you see that this works? Okay, so that is that one. So we can write this as the composition of these two. Right? Okay, another bit. Okay. So you did it. So you were able to start with a more complicated function and break it. These are basically more simple than this one, right? Right? And you were able to break it into the composition of these two. Right? All right? Okay. So like I said, you know, just like when you struggled with factoring 24, you might struggle with this for a while. Okay? Okay, now let's try another example. Let's try, how about this one? So the outside function and the inside function. So f will be called the outside, and g will be called the inside. And I want this to be f of g of x. So what, somebody else want to try it now? What's the outside function? What? Square root of x. And what's the inside function?